This lecture is on arithmetic sequences and sums. Now, a sequence, as we saw before, is a list of terms. An arithmetic sequence in particular is one in which all the terms are separated by the same amount, which is the common difference. So if you subtract any two consecutive terms, you get the same number. So you're always adding or subtracting that same number to go from term to term. So if you have this particular sequence with the nth term is 4n plus 3, then the common difference is 4. And this common difference can be thought of basically as a slope. That every time you go over one term, you're going up. 4 times 1, you're going up 4. So 4 is basically like a slope. So in this case, we've got 7 minus 5n. So your slope, so to speak, is minus 5. Your common difference is minus 5. So if n is 1, you start with 7 minus 5 is 2, and we go down 5 every time. Here we have a sequence 1/4 times n plus 3. 1/4 is your common difference, sort of like a slope. If n is equal to 1, you have a 4 times 4 is 1, and then every time you're adding 1/4. That's your common difference. This particular sequence is not arithmetic. 4 minus 1 is equal to 3, and 9 minus 4 is equal to 5. These are not the same. It's not a common difference. So clearly it's not arithmetic. Okay, to find the nth term of an arithmetic sequence, this is a formula you can use. I tend not to use it. I think it's more intuitive to think of the idea that if you want to find the 17th term of a sequence and you have the first, then to go from the first to the 17th, you've got to do 16 common differences because you're going from 1 to 17, so you multiply by 16. It's just basically the same idea as this formula, but I think it's a little bit more intuitive. So finding the nth term of an arithmetic sequence. So the common difference is 3, the first term is 2. The way that I would think of doing this is, again, the idea that the common difference is 3, so think of that as a slope as 3n. So a sub n is equal to 3n. And so now, if you just left it as a sub n is equal to 3n, and you plugged in 1, you would have 3 times 1 is 3. And we don't want 3, we want 2. So to get 3 to be 2, you've got to subtract 1, which is what they do here. So you end up with 3n minus 1. All right, writing terms of an arithmetic sequence. The 4th term is 20. The 13th term is 65. Write several terms. So to go from the 4th term to the 13th term is 9 steps, 4 to 13, and you're going from 20 to 65, which is a distance of 45. So again, you can think of it as a slope. 65 minus 20 divided by 13 minus 4, it's just sort of like a slope, and you end up with a common difference of 5. Once you know your common difference is 5, to go from the 4th term down to the 3rd, subtract 5, so you go down to 15 and down to 10 and finally down to 5. So that's one way to do that. But again, I think if you think of the common difference as a slope, for arithmetic sequences, it's a useful analogy. All right, recursion formulas. This doesn't help us too much. 7th term and first two terms are 2 and 9. The idea here is simply that if the first two terms are 2 and 9, your common difference is 7. So to get to the 7th term from the first, you have to go 1st to 7th is 6 steps. So 6 times 7 is 42. 42 and 2 is 44. All right, the sum of a finite arithmetic sequence. This is a good formula to know if you want to find the sum of n terms. But I think it's even easier if you rewrite it and basically take the 2 and put it inside. So it's written like this now. So you've got n times a sub 1 plus a sub n over 2. And you can think of this as n is your number of terms. And this expression is the average of the first and last term. So if you want to find the finite sum, this partial sum, you take the number of terms you have times the average of the first and last. So we have from 1 up to 19, we have 10 terms, and the average of 1 and 19 is 10, so 10 times 10 is 100. Sum of integers from 1 to 100, that's n is 100, and you do 1 plus 100 divided by 2, so that's 101 over 2 times 100, so 50/50. It's the same idea, they're just doing it a slightly different way. All right, the nth partial sum. So same idea of what we've been talking about, just stated differently. Find the 150th partial sum of this arithmetic sequence. So we need to find the first term, the last term, and how many terms there are. Well, there's 150 terms, we know that. The first term is 5, so all we need to find is the 150th term. And one way to do is to say, to go from the first term to the 150th, you have to go up 149 steps. Each step is 11, so you do 149 times 11. You'll end up, and then once you do that, you've got to add 5 to it. So you're doing 5 plus all of those steps. Your 150th term then is 1644. So you do 5 plus 1644 divided by 2 times 150, and you get that value there. A few more sample problems. The idea here is to find out if you have an arithmetic sequence that's 1/3, then 2/3, then 4/3 was the sequence. So we have 1/3, 2/3, 4/3, and is this arithmetic? You'll learn it's actually called geometric later. So we define the common difference. We subtract and get 1/3, we subtract and get 2/3. 1/3 is not 2/3, so therefore it's not arithmetic. In this case, we're supposed to evaluate these terms to see if it's arithmetic. So we plug in 1, 2 to the 0 is 1, plug in 2, and so on. Well, that's not a common difference. That's not arithmetic. Again, that turns out it's going to be a geometric. Here we want to find the general term, so we've got the first term and the fifth term. So to get the common difference, again, I think of it as a slope. I've got to go 4 steps, so basically 5 minus 1 from the first to the fifth, and in doing so I went from -4 to 16, which is a distance of 20, so 16 minus -4, and you can see in this form it really looks like a slope, so your common difference is 5. So now we know that we've got 5n, and if I just left it like this, my first term would be 5 times 1, which would be 5, but I want -4, so to make 5 minus 4, I got to subtract 9. Okay, same idea here. Fourth term is 16, 10th term is 46. To go from the fourth term to the 10th term is 6 steps, 10 minus 4, 6 steps. To go from 16 to 46 is a distance of 30, 46 minus 16. 30 over 6 is 5, so my common difference is 5. So I'll say 5n. And if I left it as is, my first term would be, let's do it this way, my fourth term would be 20, but I want my fourth term to be 16, so I've got to subtract 4. And then this is how you list off your first several terms. You just plug in 1, 2, 3, and so on. So in this case, you have to compare to a sub 4, because that's the one you have, not a sub 1. All right, here we want to find a partial sum. So n is equal to 50. So your common difference, as you can see, is 4. So a sub n is going to be 4n, and then our first term is -6. So to get that to be this 4 to be a -6, I've got to subtract 10. So therefore my 50th term, because I need the last one, is 4 times 50 minus 10 is 190. So now my 50th partial sum is 50, because that's how many terms there are. Average the first and the last, so -6 plus 190 divided by 2, and it's just a matter of doing the arithmetic. Okay, we're evaluating this partial sum in summation form. I put the 7 out front, so 7, and then from 51 to 100, there's 50 terms. The first term is 51, the last one's 100, divided by 2, and then going ahead and doing the arithmetic, 26,425.